Hey everyone, welcome back. Today we're going to look at solving linear systems by graphing. If you've completed the previous videos, linear function videos, and linear systems intro, then today's lesson will be a lot easier for you. So let's dive right in. Example 1, solve the linear system by graphing. So here's our system, x minus y equals negative 1, and 2x plus y equals 4. So our first equation, we can rewrite it as x plus 1. And so we can graph it like that, start at 1, over 1 up by 1, over 1 up by 1, over 1 up by 1, right, because our slope is 1. Our second equation, we can rewrite it as negative 2x plus 4. So we start at 4, down by 2 over 1, down by 2 over 1, and then we draw both of our lines like that. And we see that the solution to the system is 1 comma negative 2. This is the intersection point of our two lines. And so this is called the solution to the system. B. Here's our next system here. X minus y equals 3 and 2x plus 3 equals 6. So our first equation, we can rewrite it as x minus 3. So we go to minus 3 and our slope is 1 again, over 1 up 1, over 1 up 1, over 1 up 1. And so there's the graph of our first function. Second equation, we're going to use x and y intercepts. So when x is 0, y is 2, right? We plug in x equals 0, you see y equals 2. When y equals 0, we see that 2x equals 6, so x equals 3. And so we plot those 2 points, 0, 2, and 3, 0, like that. And so we draw the other line as such. And so we see that the solution to the system is 3, 0. Okay, C. Here's our next system here. X plus 2y equals 2, and 2x plus 4y equals 4. And so we're going to do the same thing, x, y intercepts for both. When x is 0, we get y equals 1. When we plug in y equals 0, we get x equals 2. Going to equation 2 now, if we plug in x equals 0, we get y equals 1. Plug in y equals 0, and we get x equals 2. And so we see that these points coincide, and so the lines coincide, and so we have the same line. And because we have the same line, there are infinite number of solutions to the system. D. Here's our first equation and our second equation to the system. We're going to rewrite it in slope-intercept form, so 2x minus 1, and this other one is 2x plus 2. We see here that they have the same slope, so they're parallel with different y-intercept values, and so they are parallel and they do not coincide. And so the system has no solution. Okay, practice number 1, solve the linear system by graphing. Go ahead and pause the video and answer that. Okay, we're back. So here's our system here. Equation 1 can be rewritten as 2 over 3x minus 1. Equation 2 can be rewritten as 2 over 3x plus 1. So we see that they are parallel, they have the same slope, and different y-intercepts, so they are not the same line. And so the system has no solution. Once you graph the functions, you can clearly see that there is no solution to the system. B. Here's our system here. We're going to rewrite equation 1 and equation 2 as such. So we're starting at 5, over 1 up 1, over 1 up 1. Plot those lines there. Negative x plus 1. So we're going down 1 right, and so we backtrack as such. And so we see that the solution to the system is negative 2, 3. Okay, C. Here's our system. Rewrite equation 1 as 3x plus 1. We can rewrite equation 2 also as 3x plus 1, so they are the same line, and so we're graphing that same line, and so there are infinite number of solutions to the system. D. Here's our system here. Rewrite equation 1 as y equals 3x. we can rewrite equation 2 as y equals negative 2x plus 5. So we're graphing 3x as such, negative 2x plus 5. So 5 down by 2 over 1, down by 2 over 1. Graph that as such. And so the solution to the system is 1, 3. So a couple of notes. When solving by graphing, finding the solution can be difficult and only estimated if the intersection isn't a pair of integers. And so next we will solve linear systems algebraically. And that's it. I'll see you guys in the next video.